All right, pre-calcers, chapter 1 test review starts out with factoring, but it does say completely. Pay attention to that word. So we got a 5 and a 45. Take a 5 out. A cubed, A to the first. You can take an A out. B to the 10th, B to the 7th. You can take 7 of those bad boys out. That has a C, that doesn't. So we can't take a C out. So 5 times what is 5? 1. Do you need that 1? No. Take 1A out of 3, you're left with 2. Take 7 away from 10, you're left with 3. Minus 5 times what is 45? 9. Took the A out, so it's gone. Took 7 B's out, so you're left with a C. And you're done. This guy got a negative, 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 so I'd recommend taking a negative 2 out. You can't take an x out because that doesn't have an x. So you're left with x squared plus 12x plus 35. Pay attention to that because you might not be done, and you're not, because that factors into 2 factors of 35. That's 12, 7, and 5. Don't forget this guy. He comes along for the ride, and you've factored it completely. Equation of a line, y equals mx plus b stuff. Slope is 2, so they're just spoon feeding you that. And then this is not the y-intercept, because that's 3 to the right, 12 up, so it's went somewhere up in that mystery world. So how are we going to use this? Well, this is plus b. You got to find the y-intercept. So y equals mx plus, whoopsie, x is 3 plus b. So it's minus 6, add 6, add 6. 18 equals b. You're going to put that right there. Y equals negative 2x plus 18. Dunzos. Notice this one gave you the slope. This does not. It gives you 2 points. Neither of these points are on your y-axis.
No, let me try some stuff. I'm an algebra my way. Yeah, that'll be.
All right, so continuing on. Here's x1, y1, here's x2, y2, because we're on a mission to find the slope. There's our good old slope formula, so pop things in where they belong. y2 is negative 5 minus y1, which is negative 1. We'll get to that in a minute. x2 is negative 2 minus x1, which is 6. That's a plus. So negative 5 plus 1 is negative 4. Negative 2 minus 6 is negative 8. So that reduces to 1/2. So there's our slope. But we still need to find our y-intercept. How are we going to do that? Take one of these 2 points. I'm going to choose that one. And y equals mx plus b. This is 3, so I'm going to subtract 3. Negative 4 equals b. Just a minute, gentlemen. Put that right there. Y equals 1/2 x minus 4. Done. Okay, number 5, evaluating functions. Here's f of x, here's g of x. Evaluate f of negative 4. That's just saying, let x be negative 4, put it into f, which is right here. So it'd be negative 4 squared plus 1. That's 16 plus 1 is 17. That's my answer. Inside out, find g of negative 1 first. So you pop it in there. 3 times negative 1 is negative 3. Plus 5 is 2. So this problem turns into f of 2, which means let x be 2 in f. So that's 2 squared plus 1. That's 4 plus 1, which is 5. That'll be your final answer. If you're thinking that's a booger, it's not. Tried erasing it, moving it. Don't know what that is. So we got to put all of that into f wherever x shows up, and that's right here. So that turns into x plus 5 squared plus 1. Don't take the bait and think you can square that and square that. You got to literally expand it and then FOIL it. So x times x is x squared. Outside inside is 10x. 5 is 25 plus 1. X squared plus 10x plus 26 is our final answer for that question.
you can't do it on that.
So g of 10, I'm just going to put 10 in right here. So that's 3 times 10 plus 5, which is 35. Done. Simplifying exponents. Many ways you can do this. I'm going to concentrate on the top. When the bases are the same and you're multiplying, you add. So 7 plus negative 3 is 4. There's b to the first there. Where is it warmer? It's warmer upstairs by 3. So it's like that, which is just this. Or you could have subtracted. You could have went b to the 4 minus 1, which is that. All right. Next one, PEMDAS. We got to take care of that first because this is actually in the world of PEMDAS an exponent. So we got to go x cubed. Don't make this 9. It's 27, 3 cubed. Times 3x to the 4th, which if you want to put that over 1, go for it. 3 goes into 3 once, 3 goes into 27 9 times. When you multiply and the bases are the same, you add, so it's x to the 7th over 9. Simplifying the radicals, cubic root world, you have to be careful. Cubic root of 8, cubic root of 27, cubic root 64, 125, and it just continues forever and ever. So 64 times 4 is 256. So it makes you work for it a little bit. Don't be confused. That's not the square root of 4, so don't make that a 2. And then how many times does 3 go into 5? Well, what's the number less than 5 that 3 goes into evenly?
It's 0.39.
That'd be 3. There's your perfect cubic root. You'd be left with 2. Here's your perfect cubic root. Perfect cubic root. Cubic root of 64 is 4. 3 divided by 3 is 1. And then everything else is stuck underneath the root. 4x squared. This guy, if you don't you dare cross reduce because we're not multiplying. You got to get the radical out of the basement. So we have 1 square root of 3 plus 2 square root of 3 over 3. Your brain could go 1,000 different directions, but I'm going to make this 3 over 3 because that's what 1 is, and I need common denominators. So that'd be 5 square root of 3 over 3.
Yeah, so we have to
Now we got a square root problem. You give me a second. Alright, so 245 is a strange one, and you can tell that I thought 9 might go in there evenly. It doesn't, so I just kept on trying some things. I should have known 16 and 36 wouldn't. Those are even, but I just wanted to check into them. And then 49 5 times. So this is the square root of 49 times 5. I think that's the hardest part of this problem. And then we got the square root of x squared, which is just x. And then what's the first number less than 3 that 2 goes into? Y squared, and I'd be left with 1. There's a perfect square root, 7. This just comes along for the ride. And then this is y. And I'd be left with the square root of 5y. There's your answer. This guy, get the radical out of the basement. 5, 5. So 5 square root of 5, that's a 5. And when you square root, the roots fly off, so it's really 3 times 5, which is 15. But then you got to reduce this simply because you can. So it's 1/3. So it's square root of 5 over 3. Now for the infamous piecewise functions. So really we got y equals 1. And the domain is x is less than -4. So it's -4 with an open circle. Another number less than that is -5, and that goes on forever and ever and ever. So we're going to start with that. So y equals 1. Remember, it just is 1 up, so it looked like that, but it has to start at -4. So -4, open circle to the left. Forever. Taking care of the top. So now y equals -x minus 4 take a look at the domain. X is greater than or equal to negative 4, so it's negative 4 with a filled in circle. It's still aligned, so we're going to go to 0 with an open circle. Pop that in. We get really negative 4 minus 4, a little confusing. That's just 4 minus 4, which is 0. Put a 0 in, we get negative 4. And that one does stop between there. So negative 4, 0, filled in, 0, negative 4, open, and that's a line segment. Now we've got this parabola. So when we get a parabola, I'm gonna spin it a little bit. Plus 4. The negative stays with the x squared. The positive stays with the 4. Don't mess that up. I kind of have a general idea that this is y equals x squared would look like that. Flip it would look like that. Up 4. 1, 2, 3, 4. The whole thing would look like that. Now with that in mind, I'm going to pick the domain that's required of me. X is greater than 0. So I'm going to start with 0. Open circle. And I can tell that if I put 0 in, it's going to give me that point right there, 4, but it's open circle. So 0, 4 is open circle, and another number greater than 0 is 1. So 1 squared is 1, negative 1 plus 4 is 3, so 1, 3, and I can kind of see that it's just this portion of it. So I'm going to go like this. And there we have it. This one's got less. This is just y equals negative 2x plus 5 with this domain, so it's negative 2 open circle. Negative 2 times negative 2 is 4, plus 5 is 9. And then because it's a line, I just need one more point, so I'll go negative 3. So that'd be 6 plus 5, which is 11. And it goes on forever and ever. So negative 2, 9, right here, open circle, negative 3, 11, but it goes on forever because it's a line. I have another parabola. Again, taking a quick peek at it, I know y equals x squared looks like this. You know, this is going to move it to the right one, so it's really going to look like this. That's what this is going to look like, the whole thing. But we got to limit it to that domain. So we start at negative 2, filled in circle. What's greater than negative 2? Well, we have to be careful. Plug that in there. Negative 2 plus 1 is negative 1. Squared is 1. So negative 2, 1, filled in circle is telling us somewhere in this stuff. So we should keep looking. We do know that, let's keep going here. Let's go greater than or equal to negative 2. So let's go negative 1. I think I screwed this up. I did. This is supposed to move left 1. So the brain was really doing some flip-flops. That's supposed to be left 1, my bad. So it looks like that. So if I plug negative 1 in, negative 1 plus 1 is 0. There we go. So then that's right there. And then it's just going to arc up. So we'll put a 0 in. 0 plus 1 is 1. 1 squared is 1. It's going to start moving its way up. And we can tell it's going to go like that. And there's the piecewise function. So consider the two piecewise functions above, this one, that one. Are they continuous? No. How do you know? If this was a roller coaster, you would die. Because that'd be killer. Be killer. They didn't finish the roller coaster. Alright, let's go on to the next one here. Oh, this is a pain, but give me a second. And number 14, consider the two piecewise functions. They're talking about that and this. It says find f of negative 5. So first of all, only use f, not g, and find out where x can equal negative 5. Well, if x is less than negative 4, that'd be less than negative 4, so that's true. So, this is kind of weird, but y equals 1. I mean, it has to. It equals 1. Because y always equals 1 for that whole function. Y equals 1 for that whole domain. That's what it's saying. All right. Now negative 1. Negative 1, where's that possible? Well, again, it's f. So we've got to focus here. Negative 1 is right in here. So when we plug negative 1 in right here, what's the negative, the opposite of a negative 1? That would be 1. And if you looked at the drawing,
And it's 22.4 divided by log of.
whoa, something went wrong. So I just discovered a mistake. Wish I would have caught it earlier, but right there, negative 4 is 0. Where'd that 0 come from? I have no idea. If I put negative 4 in for this,
Oh, for the test. I think he was doing this. I was like that. You don't make videos.
hold on. Okay, so Mr. K's a little blind. I'm going to blame these. But actually it's my brain, not my eyes. But I ignored that comma when I did this. This is the domain. This is the equation. I don't know what happened. I'm in a hurry. Put the negative 4 in there. That'd be a positive 4, not 0. So that changes a lot. So negative 4 should have been here and then here. Alright, my bad. But if we put negative 1 in there, the opposite of negative 1 is 1. I got that one right. So anyways, go on to this one, g of 4. So now I got to take a look down here. What domain allows me to let x be 4? That'd be here. X is greater than or equal to negative 2. So I got to put that 4 in here. 4 plus 1 is 5. 5 squared is 25. Done. Okay, see if we can handle these inverse functions, which are written like this-ish. So if it's h of x, we are not done until we have this. So step 1, we're going to replace that with a y. Step 2, I'm going to put a little squiggly line here. You switch the x's and the y's. So what you just did is you literally, thank you very much, you literally introduced this right here. Now we need to solve for y. So we're going to add 3. I'm flipping this thing around. 2y plus 6 equals x plus 3. Got to square both sides to get rid of that square root. 2y plus 6 equals x plus 3 times x plus 3. So we get x squared plus 6x plus 9. Alright, had to sharpen the old pencil. So now we got to solve for y. Throw it all over 2. So y equals x squared plus 6x plus 3 all over 2, but then this is now the inverse function, so we replace it with that terminology or that symbol. And we're done. That's what that's saying. Switch the letters, solve for y. So 2y squared, I'm going to add 10 to both sides, is x plus 10. Divide by 2, so I get y squared equals x plus 10 all over 2. Bada boom, bada bing, do the right thing. Don't forget that. So we get y equals plus or minus the square root of x the inverse function of f. We started with that, now we have the inverse function. Done. Same thing here. Y equals x plus 1 all over 2x minus 5, step 1. Step 2, switch all our y's and our y. Multiply this by 2y minus 5. Sorry about this mess here. Distribute. I get 2xy minus 5x equals y plus 1. Don't forget we're trying to solve for y, so we got to gather our y's and get everything else on the other side. That's a big equals 1 plus 5x. We're almost home. Divide by 2x minus 1. I know that's y, but I got to replace it with the inverse symbol. And then I'm left with 1 plus 5x all over 2x minus 1. And there's my inverse function. And we're going to call that good for this video.